Now we are on convergent series or sum to infinity. So this is a continuation of geometric sequence of geometric series. But now there is a point where we say now our geometric sequence have converged. That's when our ratio lies in between -1 less than r, which is less than 1. Once our ratio is in between these, two numbers, it means now the geometric sequence series have converged, or it is sum to infinity. It will be approaching infinity. The sum will not end, it approaches. So what we have to do here, sometimes they can ask you to check whether what are the values of x at which the following sequence will converge or exist. So let's see how do we do that. Let's have an example. Given the series, three 2x minus 3 squared plus and it says for which values of x will the series converge. So what we do here is we find the value of r. R is t2 divided by t1. Our t2 is 3, 2x minus 3 cubed over 3, 2x minus 3 squared. So these values, they cancel out. By laws of exponents, the base is the same. So 3 minus 2 is 1. So our ratio is 2x minus 3. So now we take it here. We know that for it to converge, it must support this condition. So minus 1 is less than 2x minus 3, which is less than 1. But now we don't need the value, we need the value of x. In this case, it is not solved. So how do we solve this? We can split it into two, as what we did when solving inequalities. So minus 1 is less than 2x minus 3, or 2x minus 3 is less than 1, because this one is being shared this side and that side. So let's take this one this side. It becomes minus 1 plus 3. We get minus 1 plus 3, we get a 2, which is less than 2x. Then here 2x is less than, we take this one that side, becomes plus 3, it's a 4. So x here we divide by 2 both sides, we get 1 less than x. Here is 2 less than 2, or it's x less than 2, sorry. So now our solution will be like this. Here it is joined. It joins 1 is less than x, which is less than 2. So that is our solution. At 1 less than x less than 2, that series will converge. Let sum to infinity if summation of 8 multiplied by 4 raised to power 1 minus p from p1 up to infinity. So what we do here, we have a formula for calculating sum to infinity, which is equal to a over 1 minus r. R must not be equal to 1. That's the condition. So what we need to do there is to find the sequence, because we don't have the r. So we need to come up with a series that will follow our notation there. So we substitute with p1 first, followed by p2, followed by p3. So this will be 8, which is T1, multiplied by 4, 1 minus 1. This is equal to 8. Then T2 is 8, 4, 1 minus 2. What is 1 minus 2? Is equivalent to minus half. So this one will be a 2. Then T3 is 8, 4 power 1 minus 3. 1 minus 3 is equal to, we get minus 2, then which is half. If you simplify on your calculator and get those values. Then from there, now we need to find the ratio R is equal to T2 divided by T1. Our T2 is 2 divided by 8, which is equal to 1/4, or you can calculate it like this: T3 divided by T2. T3 is half divided by 2. The sign we invert to change to 1/2, which is to 1/4. So now on our sum to infinity, it's A. A is the first term, which is 8, or T1, over 1 minus R is 1/4. This is 1/4. Then 1 minus 1/4 is 3/4. If we simplify here, it becomes 32/3. That will be our sum to infinity.